Warm greetings to all. In last video, we saw about the introduction to sequential circuits and latches. In this video, we are going to see about flip-flop and its types. A flip-flop is an electronic circuit with two stable states that can be used to store binary data. The term flip-flop is used as they can switch between the states under the influence of a control signal, that is, they can flip to one state and flop back to other state. Flip-flop are extensively used in counters, frequency dividers, shift registers, storage registers. There are 5 different types: SR flip-flop, D flip-flop, JK flip-flop, T flip-flop and master slave flip-flop. First type of flip-flop is SR flip-flop. The SR flip-flop is a 1-bit memory bistable device having 2 inputs, that is, set and reset. If the set input is high when the clock is triggered, the Q output goes high. If the reset input is high when the clock is triggered, the output goes low. The symbol for the SR flip-flop is shown in this slide. The circuit diagram and the state table of SR flip-flop are shown in this slide. This circuit has 2 inputs S and R and 2 outputs Q of t and Q of t dash. Here Q of t and Q of t plus 1 are present state and next state respectively. The operation of SR flip-flop is similar to SR latch. A 2-input NOR gate produces an output 1 if all the inputs are 0 and produces an output 0 even when one of the input is 1. So, when both the inputs are 0, the output Q of t plus 1 is Q of t. That is, there is no change in the output. When S is equal to 0 and R is equivalent to 1, output is 0. That is a reset state. When S is equivalent to 1 and R is equivalent to 0, the output is 1. That is set state. At any time, only one of those inputs should be 1. If both inputs are 1, then the next state Q of t plus 1 value is undefined. The next type of flip-flop is D flip-flop. The D flip-flop is the most important flip-flop from other clocked types. The delay flip-flop is designed using a SR flip-flop with an inverter connected between the inputs, allowing for a single input D, that is data. It ensures that at the same time both the inputs, that is S and R, are never equal to 1. The symbol for D flip-flop is shown here. This slide gives the circuit diagram and the state table of D flip-flop. From the figure, one can see that the D input is connected to the S input and the complement of the D input is connected to the R input. The D input is passed on to the flip-flop when the value of clock pulse is 1. When clock pulse is high, the flip-flop moves to the set state. If it is 0, the flip-flop switches to the clear state. If t is equal to 0, S equal to 0 and R is equal to 1, then next state Q of t plus 1 will be equal to 0. If D is equivalent to 1, S is equal to 1 and R is equivalent to 0, then next state Q of t plus 1 will be equal to 1. Next is JK flip-flop. A JK flip-flop is the modification of the SR flip-flop. The only difference is that the indeterminate state is more refined and precise than that of a SR flip-flop. The symbol for JK flip-flop is shown here. The behavior of inputs J and K is same as the S and R input of the SR flip-flop. The letter J stands for set and the letter K stands for clear. The circuit includes two 3-input AND gates. The output Q of the flip-flop is returned back as a feedback to the input of the AND along with the other inputs like K and clock pulse. The operation of JK flip-flop is similar to SR. When both the inputs J and K have a high state, the flip-flop switch to the complement state. So, for a value of Q equal to 1, it switches to Q equal to 0, and for a value of Q equal to 0, it switches to Q equal to 1. T flip-flop is much simpler version of the JK flip-flop. Both J and K inputs are connected together and thus are called a single input JK flip-flop. When clock pulse is given to the flip-flop, the output begins to toggle. The symbol for T flip-flop is on here. The circuit has a single input T and two outputs Q of T and Q of T dash. The operation of T flip-flop is same as that of JK flip-flop. The output of T flip-flop always toggles for every positive transition of the clock signal when input T remains at logic high 1. The master-slave flip-flop is basically a combination of two different JK flip-flop connected together in a series configuration. Out of these, one acts as the master and the other as a slave. The output from the master flip-flop is connected to the two inputs of the slave flip-flop, whose output is fed back to inputs of the master. In addition to these two flip-flop, the circuit also includes an inverter. The inverter is connected to clock pulse in such a way that the inverted clock pulse is given to the slave flip-flop. In other words, if Cp is equal to 0 for a master flip-flop, then Cp equal to 1 for a slave flip-flop, and if Cp equal to 1 for master flip-flop, then it becomes 0 for slave flip-flop. When the clock pulses goes to 1, the slave is isolated. J and K inputs may affect the state of the system. The slave flip-flop is isolated until the clock pulse goes to 0. When the clock pulse goes back to 0, information is passed from the master to the slave and output is obtained. Firstly, the master flip-flop is positive level triggered and the slave flip-flop is negative level triggered. So, the master responds before the slave. If J equal to 0 and K equal to 1, the high Q output of the master goes to the K input of the slave and the clock forces the slave to reset. Thus, the slave copies the master. If J equal to 1 and K equal to 0, the high Q output of the master goes to the J input of the slave and the negative transition of the clock sets the slave copying the master. If J equal to 1 and K equal to 1, it toggles on the positive transition of the clock and thus the slave toggles on the negative transition of the clock. If J equal to 0 and K equal to 0, the flip-flop is disabled and Q remains unchanged. Thank you.